Oh, yes. It's an unboxing video, guys. I know you guys love these things. You know, I don't actually do repairs. I'm not a technician. And you know how I work on radios. Usually I'm cutting corners. I'm not doing the right procedure. My soldering's not that good. I'm using the wrong kind of wire. I barely have, the proper tools to keep my equipment running. And, my videos are all about making mistakes, trying something, making another mistake, and then coming out with something that works. I want the radio to work, obviously, right? You want the electronics to work. It's not to make it look pristine, but presentable. So I'm not your repair guy. But occasionally people will send things along. And here's how they trick me. They'll say, Mike, I'm sending a radio that probably has never seen the light of day before. This is so rare. It probably was on the space shuttle. This radio is a spy set that is undocumented. This is a premium receiver that nobody knows about, that probably 007 used once in Japan. That kind of thing. So those are the kinds of ways that people trick me to send something in. Can you just look at it? Okay. If I look at it like this, that's $50. If I look at it like this, however, that's $100 look. Okay? So we've got that too. I can put a price on looking at the radio. Okay, let's open this thing. Enough fooling around. This is supposed to be a very fancy receiver. I showed you that picture of the Watkins Johnson that I have, 8711 receiver. A lot of people think that's a good receiver. Some people think it's passable. Corners were cut. It's not as good as it should be. You get all kinds of comments. But it is considered a premium receiver. Any receiver that costs more than $4,000 or $5,000 has got to be a good receiver, right? So let's see what constitutes a premium receiver to take a look at. We're going to look. Okay. Oh, it's really well packaged. Da-da-da-da-da. Dear Michael, when I turn the radio on, I hear a humming sound. Excellent. Can the sound be eliminated? Can that sound be eliminated? When I turn on the volume knob, the sound periodically jumps around, creating at times a piercing sound. Interesting. I'm concerned about damaging the speaker. Why is the band spread knob farther away from the cabinet, unlike the tuning knob? Well, these advanced receivers, they do stuff like that. It's ergonomics. You guys know about ergonomics, right? Sometimes I experience ghosting when listening to some AM stations while the unit is connected. Ghosting. Maybe he has come to the right place. I do like radios that have ghosts. The ghost in the machine, you guys have all heard of that. Anyway, let's see what this thing is. Enough talking. Let's put this away so I don't sit on it, right? I'm so excited about this. I don't even know what to do. Petralgia. Any idea? Okay. This must be from oh, hold it. This could be from Italy. That could be a foreign language. Fragile. Exactly. This is probably from Italy. Let's get this out of there. Okay. Okay. We're making progress. We're making progress. This unboxing stuff, we don't have videos like this every day. Takes a little bit of time to get this in here. Okay, come on. How much bubble wrap do we need? This thing, oh my Lord. Look at what we got. Wow. This is an S-38A. This is even better than what I expected to get. Look at this thing. Well, I'm very excited. First of all, I'll be more excited to get rid of all this bubble wrap. So let's do that without hurting the radio. Okay. This turns out to be a pretty good radio to have on the channel. Why? Because the S-38A represents every man's radio. This might have been the radio that you had as a novice, or maybe as a beginning shortwave listener in the late 60s, early 70s. Everybody knows about the Hallicrafters, right? So an S-38, hey, maybe this is a good one to go through on the channel. These radios were called widowmakers by some because, they have the cord, that doesn't have the polarity, and you get across the chassis, you get a shock. Pretty soon, you're in cardiac arrest. The ambulance comes, they take you to the hospital, and what do? They hit you with more electricity. Like that's going to fix it, Anyway, I would just use another S-38 and bring yourself back. So anyway, let's see what we can do with this receiver. And we have a good list of things that the owner of this receiver does not like. So let's go through them one at a time, find out what's going on with this beautiful S-38A.
The Hallicrafters S-38A is the first revision of the S-38 tabletop shortwave and broadcast receiver, first introduced in 1946. The S-38 series, which spanned from 1946 till 1961, represents one of the most popular, if not the highest production, entry-level post-war receiver of all time. The receiver is really a glorified All-American 5, and it's in the all-octal tube lineup. Hallicrafters hired one of the greatest artists of the Art Deco movement, Raymond Lowry, to design the front panel. The size and the classic Art Deco styling, as well as the onboard speaker, made this the perfect entry-level radio for a whole generation of post-war shortwave listeners and beginning hams. The S-38 is an AC-DC, off-the-line series string, 5-tube single conversion superheterodyne. It has a 455 kHz IF. Again, these sets use the common octal All-American 5 lineup. The 12SA7, the 12SK7, 12SQ7, 50L6, and 35Z5. The S-38A model lowered the cost and complexity of the S-38 by eliminating the dedicated BFO function as well as the automatic noise limiter and their associated controls and switches. Also, it got rid of one tube, an extra 12SQ7, and they replaced the original 35L6 in the S-38 with a 50L6, which was a more common, less expensive tube. A rather clever and somewhat reviled IF feedback regenerative circuit with a switch provided the only BFO service on the receiver. This Hallicrafter receiver tuned 4 bands: the broadcast band 0.55 to 1.65 MHz, shortwave 1 1.7 to 5.1 MHz, shortwave 2 5 to 14.5 MHz, and finally band 4 at 13 to 31 MHz. This band plan was cleverly set up to center the 80 and 40 meter ham bands right in the middle of band 2 and 3, with good band spread. The first year price of the S-38A around 1948 was $39.95. The receiver was sold by Sears, which made it very much a dream receiver for a whole generation of young shortwave listeners and novices. Let's go through the schematic on the S-38A. The first thing that's fairly novel for an entry-level receiver is the balanced front-end primary coils on the input tuned circuits. This radio would actually work with a true balanced line dipole arrangement. 75 ohm twisted or solid balanced feed line could be used with the receiver. A shorting bar allowed one side to be connected to a bypassed ground terminal for safe single-ended unbalanced connection to coaxial and single-wire antennas. Hallicrafters provided 2 RF input transformers, one for bands 1 through 3 and a dedicated one for Band 4, the higher frequencies. Band 4 required a dedicated coil with more performance and image rejection. The input tuning networks are a series of primaries and tunable secondaries. Interestingly, a dedicated primary is used for the AM band. Bands 2 and 3 share a common primary, and Band 4 is a totally separate transformer. These are band switched in concert with the local oscillator. Automatic gain control is delivered to the grid circuit through tuned secondaries on bands 1 through 3, but on band 4, AGC is eliminated in favor of fixed bias for a wide open converter gain at all times. This improves band 4's high frequency noise figure and gain. Both main tuning and band spread tuning variables were provided on all bands, and there's something unusual about the local oscillator circuit here. On the surface, the reflex local oscillator of the 12SA7 pentagrid converter consists of 4 Hartley-style oscillators. These are all slave to the band switch. It all looks pretty normal, but there is some Hallicrafters trickery here. Take a look at the 2 general oscillator topologies used with most pentagrid converters. As you can see, one is Hartley and one is an Armstrong oscillator, or more properly, according to the Europeans, a Meissner oscillator, which includes a feedback coil. It appears that they have provided compound feedback in the form of an added winding that comes from the screen grid, which is hot to RF through that coil. Being a small inductance, that means it had very low mutual coupling basically only to the band 4 coil. This coil would be invisible on bands 1 through 3, which required a bypass screen grid. But on band 4, it would encourage oscillation to offset the lowered gain of the 12SA7. Leave it to those very capable Hallicrafters engineers to throw in a circuit that's quite novel in the S-38. This is their low-end receiver. As far as I've been able to research, this hybrid oscillator circuit has never been described in the literature. My theory here is that the 12SA7, designed for All-American 5 broadcast receivers, starts to have low gain or troublesome capacitances at the higher frequencies, and this additional feedback guarantees oscillation at the very high frequencies. Comments please if someone has a better idea on what they're trying to do here. They flip from high side injection to low side injection on band 4. The intermediate frequency for the set is a standard 455 kHz, and V2 is a 12SK7. It's the only IF amplifier. The set has 2 IF transformers, so don't expect too much selectivity. It's going to be a lot like an All-American 5 receiver. The IF stage is doing double duty as an amplifier, and in the S-38A and B as a beat frequency oscillator. Tempting the IF to oscillate is an interesting idea. This is similar to a Q multiplier idea. But this cost-cutting approach, it eliminates one tube, RF transformers, switches, variable BFO control, a couple of other components from the parts list. This makes the original dedicated BFO approach of the S-38 quite desirable. The S-38 is the most desirable in the line, and it's the original. Tempting the IF tube to act as a tune plate, tune grid oscillating BFO, and as a kind of regenerating IF amplifier simultaneously, is tricky stuff, as we will see. Next in line is the detector and audio amplifier stage, the 12SQ7. This is a conventional detector amplifier, with the detector also providing negative AGC voltage, and the triode providing the very high gain you need in the audio preamplifier. The volume control arrangement here with the 2 meg potentiometer represents the most sensitive part of the audio chain, and it's normally the most important area in terms of wiring technique to achieve low hum, of course after the power supply ripple problem. The S-38A retains the true AC-DC nature of all All-American 5 radios. This radio, like many All-American 5 types, can be run on 117 volts AC, 50 or 60 hertz, or 90 to 120 volts DC. This is a leftover from the 1920s Edison DC grid standard, when 120 volts DC power was common. In the event of a power failure, massive banks of batteries backed up the DC line. This was like having a giant citywide UPS. The AC-DC war rages on, with the most modern electric vehicle power systems and motors competing. Tesla and Edison are apparently still at war. Especially today, this quirky AC-DC ability that's built into the S-38 actually tempts a number of isolation solutions beyond that of a simple isolation transformer. Cost reduction. By eliminating the second 12SQ7 used in the original S-38 for the dedicated BFO, and the power amplifier changing from the 30L6 to the more economical 50L6, cost was cut. The 35Z5 remains as the power supply rectifier. This standard tube also provides facilities for a pilot lamp as part of the series filament chain. Speaking of power supply, this set is fairly conventional in terms of the off-the-line design and its safety features. The prevention of an off-the-line shock hazard is dependent on the set's isolation. A floating ground remains isolated from the outer metal case. All protection is via the breakdown and leakage ratings of key capacitors. As these aged, more and more current could flow into the chassis, and the chassis became a tickler. If the capacitor continued to break down, suddenly the full line voltage could appear on the outside of the chassis. This would happen if the AC line cord were flipped in the socket so that the hot part of the line cord was connected to the artificial ground. At this point, the case could begin to produce a shock hazard, and should the unsuspecting person get between the case and a well-grounded point, like some other piece of equipment in your ham shack, nasty, sometimes even lethal, shock hazards were the result. So this capacitor breakdown was a serious problem. It's apparent that any radio with a metal outer case is more likely to cause a shock hazard than a radio with a wooden or plastic case. Hallicrafters was clever, however, in using the natural isolation of transformers on the balanced antenna and headphone connections. So you cannot easily get zapped from those terminals, at least. The good news is that these modest commercial shortwave radios generally remained 100% safe over their first 20 to 25 years of use, had a full underwriter's laboratory approval. But we all know that parts and cords age. The real issue was and is that we continued to use these off-the-line radios well beyond their life expectancy. More on this in Part 2, where we carefully attempt to power up and go into the S-38's cabinet and see what we got in there, and not necessarily in that order.
So I have a little more information about the receiver. You know, there's a big controversy about AC-DC series string type radios like the S-38 and many others, especially in the early days of the AC-DC type radios. There were some pretty dangerous wiring practices in the series strings. Now, by the time of the S-38 and even into the time of the S-120, certain improvements have been made in series string AC-DC type setups where there was good isolation between the artificial ground inside and the outside case. As a double protection, many All-American 5 radios used plastic cases, which guaranteed, along with a cheater cord and a fiberboard back panel, that it would be very difficult, unless you threw the radio into the bathtub, of causing a lethal situation. You have to remember that these radios were made to have a low-cost solution, and the series heater string was responsible for many millions of radios that were out there. This radio alone had a production run probably in its series of well over 500,000 units. So that's a lot of radios. This was a very popular model. To think of them all as killers is the wrong way of thinking. However, what is the lifespan of a radio? When you put capacitors in a radio, do you expect the radio to last forever? Let's say a 20 or 25-year lifespan on the parts is a normal span. Well, here we are in the 21st century, 50 years later, expecting these radios to still be able to provide the same performance. I don't think so. So by replacing the capacitors inside the set with modern equivalents, by using a 3-wire cord that kind of helps you with the AC outlet, testing your outlet, so on, there's no reason why you would need to use an isolation transformer on a radio like this. However, I found out that the radio does indeed have an isolation transformer that has been added to it. This radio has been modified. I found that out from the owner. So we're going to see what the addition of an isolation transformer has done to this set. We're going to see the positives and we're going to see the negatives. Also, notice that an inline switch fuse system has been added here, and it is a polarized 2-wire cord. So let's see how that's set up in the radio. In part 2, we'll get a little deeper into the set. We'll finally take the cover off, see what it looks like inside, and see if we can get the ghosts out of this radio.